Hey guys, what's up? Eddie Alho here with KissAnalog.com. Alright, today's going to be fun. I have a power cord. We're going to put power on this Class D amp. So it's going to be kind of cool. Well, hopefully it will be. So the one test I want to do is I want to do a bode plot. I want to see how flat this guy is from, it says it's pretty flat from 20 hertz to 20 kilohertz. So I want to verify that. We'll use the bode plot here on this GW Instek Oscilloscope. So I'm going to use these big old 200 watt load resistors. Now, to put 200 watts into a 200 watt resistor, it will get hot real fast and be really bloody hot. So I don't know if we're going to do a full power test today, but we might if we have time. And okay, so here, let me just show you the schematic of what we're set up to do. Here's the power cord I made. Has a switch in it, has the fuse, and the NTC, and that guy's for inrush current. Starts off 10 ohms. It's rated for 9 amps continuous. Around half of that, it drops to 0.2 ohms, and at full current drops to, I think it's 0.1 ohm. Okay, so that'll help in the inrush current. So I'm just kind of showing a connector to the board, to the power supply card. Power supply card has the two parts of it. The first stage is the PFC, power factor correction. It's a boost converter, essentially. Second stage is a LLC converter, type of resonant converter, and it'll put out a plus minus 32 volts DC, isolated from the input side. So there's a transformer in this part, boost inductor here, transformer in this part. The output has 6 wires, and I took a look at it. What it is 2 of them are plus 32, 2 are minus 32, and 2 are return. So I guess to carry all that current. And it's kind of a semi-stiff cable, so I can tell the gauge of the wires, you know, good enough to do what we're doing here. So the power supply is rated at 400 watts continuous, 550 for peak. Now this guy rated 200 watts per channel into 8 ohms. So what we're going to do is we're going to check that flatness from the 20 hertz to the 20 kilohertz into 8 ohms. So I have these 8 ohm speakers tied to it, and we'll run it at 1 kilohertz, 1 watt. That's kind of the typical measurement values. So what I did is I showed my oscilloscope over here. One of them is going to be tied, it's going to be injecting a signal into the input, and it'll be monitoring that input signal. The other one is going to be the output, and it's going to be looking at the we'll just look across one of these two outputs. I called one A output, one B output, but we'll monitor one of these outputs, and then the bode plot will be output divided by input, it'll be the gain. Let's do it. And by the way, yeah, GaN Systems provided this eval card. They're the 2 eval cards, so pretty nice of them. Thanks, GaN. Okay, let's do it. I'm going to bring you over first, show you a close-up of the test setup, the board's the test setup, and then we'll look at the scope and run the test. Okay? Alright, let's do it. Okay guys, so let's go over the setup real quick. We got our 2 cards, the amplifier, the power supply, and we've got this cable here that came with it that ties the 2 together. And then the other cable is the input power supply cable, the power cord, and one lead goes through the switch, through the fuse, and up into this input on this side. And then the other one, the red one, comes up through here and goes through the NTC into the other pin for the power. And on the board, of course, there's a fuse on the board as well, so we've got kind of 2 fuses backing ourselves up. And then EMI filter, bridge rectifier, boost converter. There's a little NTC down here in the corner as well for this boost converter. Then we come over here through our LLC, and we have our 2 output stages, our plus minus 32. So as far as GaNs go, if you can see it, one of them is right down there, the gold guy. This gold guy right down here, that's the one for the boost. And then these 2 guys are here for the LLC. Okay, then we come over here and we've got our output stages tied to our two 200-watt resistors, 8 ohms. And we've got a differential probe looking at one of the outputs. And that's this differential probe right here, the Pintec. It's in ×20 position. The other differential probe is in ×50, and it is looking at the input. And the input is this coax right here coming from the scope, the generator output of the scope. So the oscilloscope will sweep this signal right here across the band. So we'll look at the input, we'll look at the output, and it'll be output divided by input. Okay? So I think we got that covered. I'm going to plug this in. I wish I had my Variac. I think I have a Variac in storage, but because I'm not a big fan of the not a big fan of I'm not a big fan of the old you know, smoke test, but we're going to hope this is all proven out, the circuit and everything. There's no signal coming in right now, so it should just come up with 0 signal. Then what I'll do is I'll turn this digital pot counterclockwise to turn the volume down, and then we'll find out where we need to set this to get a good sweep. Okay, because what we're going to do is we're going to want to set it for 1 watt. And then all these switches here, once we power up, there's a bunch of LEDs I noticed on this board, and this guy appears for what input, and there's different LEDs. There's optical, which is this guy. The next LED is the coax, then the RCA where we are, then the 3.5 millimeter, which is this little jack. So we'll sit here and toggle this guy and select this RCA. And then this guy here allows you to go open loop or closed loop. So we'll make sure we close loop, and I think we'll try it both ways, right? Okay. And then this guy is a reset for the pick. The pick is underneath the board. I showed that in my last video. And this guy here is for the peripheral reset, which I'm assuming is this guy. Not sure. There's a couple controllers on the back and then this big guy up here. So those are resets. And you can see the big output stage, big inductors here. And the GaNs, move my probes here. See the 2 guys there, the black guys? Then there's 2 here, another 2, and another 2. So you got 4 per stage, because it's, and so with each pair of FETs you have an inductor, and so this speaker is tied between these 2. This speaker, or you know, simulating my speaker, is tied between these 2. Okay, yeah, pretty amazing, impressive. Look at that, no heat sinking, just PCB. No heat sinking on the power supply. Pretty crazy. Alright, let's get ready to do the smoke test. Okay, I've plugged in my cord into the outlet. This switch, I've ohmed it because I always do, even though I know how it's set. When this toggle is away from these 2 positions, I kind of look at this outside position here. When it's towards an outside position, it's off. When it's away from it, it's on. But I always ohm them before I get ready, so I'm not surprised. And then, there we go, my plastic shield. Because if smoke does come out, that's all I want. I don't want any particles. And I might even put on my safety glasses. Thought I was joking, huh? I have something here. Better be safe than sorry, right? Alright guys, so what I did is I kind of angled this, just cover these big aluminum electrolytics in case something terrible happens. I'm going to go ahead and fire it up. And see these LEDs here? So I kind of dimmed my lighting. So hopefully they'll show up. But there's LEDs here. There's some over here too. There's probably going to be LEDs popping up on this board. I didn't really look very close for all of these LEDs. I started noticing them after I did the last video. But okay, so let's just go ahead and power up, and here we go. Down here in the lower corner, if you can see my finger, I'm going to... Whoa, I saw a red light flash right there. Okay, green lights are good. Hey, look at that. So Whoops. Okay, so this looks like it defaulted to open loop. I'm gonna, oh nice, closed loop. But look at this. I wonder if it sensed that I have a signal here. Okay, I'm gonna scroll that down, by the way. Okay, I see an LED down in here. Looking for other LEDs. Okay, there's an LED there. There's one there. I zoomed in so you can kind of see. I don't see any others over here. Oh, here's one over here by the connector. I thought I saw one somewhere. So there's at least one right there by the output. Here on the power supply, I don't think I see any LEDs there. But over here I do. Okay, I'm going to go ahead and turn off the switch for a moment. Alright, so let's just go over this scope setup. I've got the two differential scope probes coming in here, and we've got the output on channel 2, the input on channel 1. Okay, so the Pintec DP25's here, the Mixig DP10013 is on this guy. Okay, so when I hit this, you can see I've got this guy set for times 50, the Mixig, and the Pintec times 20. Full bandwidth on both, and DC coupling on both. Okay, so there's our setup. Now I've got the channel 1 500 millivolts per division. So right now I've got about, you know, almost a volt going into RMS. Channel 2 I've got 2 volts per division and almost about 2 volts RMS. Alright, so I'm going to bring that up just a little bit. Alright, so I want about 2.8 volts here. So I'm going to go ahead and bring up the volume on the, okay, there's 2, oh, there's 3. Okay, we got about 2.8. We'll just go slightly over, because it looks like I'm either above or below. Okay, so there we are. Now, look at that noise. Interesting, right? So I can hit the zoom function and zoom right in on that. And then maybe we'll sweep over here and look at this edge. So look at the output. That guy is, okay, right there. I'm 1 microsecond per division. I'm going to freeze it for just a moment. Let's see, 1, 2, about 3 microseconds. So pretty high frequency. It's about 400 kilohertz right there. And meanwhile, even though that looks kind of bad, amazingly, the THD meter only shows about 0.01. It kind of jumps up to 0.01 sometimes. Yeah, see that? And I've got that reading up to 9 harmonics. Alright, so that's going to be roughly about 1 watt at 1 kilohertz. So that's kind of my calibration. So then what I want to do is, if I go to the generator, I can see it's set for 1.3 volts peak to peak. So I'll make sure I do that when I set up the sweep. So let's go ahead and do that. What we do is go to app, and then go down app button and choose the FRA, frequency response analysis. Select that. Yes, I want to do it. Alright, so now we got to set that up. So let's say I'm going to go to generator right off the bat, so I remember this is going to be 1.3 volts peak to peak. Okay, now we're calibration set up. Now we're going to start this at 10 hertz. Okay, 20 hertz I think is as low as I can go on the scope here, so that's good. Oh yeah, well we're going to go 20 hertz to 200K, but I want to start at decades, but that's alright. Let's go back. So that's our stop, and our stop is going to be, I guess, I'm going to choose 100K. So we'll sweep out to 100K. Okay, there's 100K there. So 20 to 100, 1.3. Oh, and that is volts peak to peak. Okay. And we'll leave that on low Z. Now here's a reference circuit. Okay, device under test. So, you know, you don't have to be hooked up to channel 1, 2. You can select anything you want, but generator into 1. That's kind of how we have it set up though. So we're following that. So go back to setup. Our input is going to be channel 1. Our output is going to be channel 2. See what I mean? You can choose any one of the 4. That was just an example. Alright, and okay, let's go ahead and run the generator. Now, if you haven't seen me do this before, oh, I have to actually turn on the, oh, yeah. You know what? The last time I set it, I was using channel 1 and 3, so even though I set it up, I have to turn on the channel. Alright, so now it's all set up. Up here, we're going to see the wave, the input and the output, so we'll be able to watch them. The scope's going to automatically adjust for that and all that, so let's go ahead and do it. Oh, this is kind of a bummer. It says it only supports 10K, so I wish it would just say, do I want to set it and do it for me. But I have to come over here, acquire, and drop down to 10K, because it takes so much math to do this that, you know, it has to set up properly with the right resolution. Okay, now let's run it. We're finally ready. Do it. Get rid of that menu right there. Phase is red right here, and auto adjusts the scale as it scrolls across. The gain is the blue. Yeah, when I see something like that, I just don't believe it. It just looks kind of weird. Usually when I see something that with where it just doesn't seem like it can take the right math and do the right thing, there's not enough signal. So you know what, let's go back and let's do setup. Well, as I'm looking at this, it looks correct. Input, output, channel 2. So you know what I think we ought to do? Now we can take more readings on this guy right here. Right now it's set for 10. Okay, there's 10. It was set for 15. There's 30 all the way up to 90. Let's just go up to 30 and see if we take more readings, if it gets you know, better resolution and it actually works. We might have to step up the signal. Let's try it again. Okay, we can see the generated signals up here, and they do look really out of phase. So it's showing 10 dBs. Wow. Okay, that's interesting. When I'm watching the signal up here, they don't look like they're in phase. They're kind of jumping all over the place. Well, that's kind of crazy. The amplitude was around 10 dB, and then it just takes a serious drop just after 20. But that phase just looks crazy. But yeah, isn't that interesting how it goes just past 20 kilohertz, and then it goes from 10, just boom, just drops right off the picture. That's one heck of a filter. But look how flat that is from all the way out 20 kilohertz. This is the part that it's made me wonder. You know what I think I want to do is pump up the volume. Let's increase the amplitude, see what happens. Let's go to generator setup, amplitude. Okay, we'll go up to 1.8. Maybe we'll just go to 2 volts peak to peak. What the heck? Let's try that. Okay, everything else looks okay. Let's go ahead and run it. Get rid of that window there. Now, that looks like it's clipping big time. And my distortion is up to 12%. So I'm going to go ahead and lower the volume on this input. There we go. See that blue waveform getting better. Yeah, I think I lowered it too much, so it's not seeing any signal now. Alright, well, yeah, this part here, the gain actually might be correct how I was adjusting the volume over there, but that phase just looks crazy. And that gain went way too high. Alright guys, we're back to our calibration screen, okay? About 2.8 volts here, roughly, RMS, and about 0.8 volts coming in. And you see how they're out of phase? So that's a 1 kilohertz. Let's pull up the generator. Generator 1. Waveforms. Okay, 1.3 volts peak to peak. That's our calibration. Okay, frequencies right there, 1K. So let's go ahead and just start increasing our frequency. It's 2K, 3K. We're going to do this by hand. Look at that, 3K. It's 180 degrees out of phase. And then, wow, that's crazy. 4K, okay, 3K. Then look at 4K. Alright, so that's 3K. 2K looks like they're not too far out, right? And 3K, all of a sudden they flip. They're like 180. 4K, the input is ahead of the output. Input comes up first, then output. Let's go back to 2K. I forget what that was. Okay, 2K, the output's coming up first. Okay, then we go to 3K. They're almost 180. 4 outputs coming up after. Look at 5K is almost right on. Wow, this phasing just blows me away. And then 6. This thing has to have some digital filtering in it because like 8K it's back to get, 9K it's the output's behind again. 10 it's about 180. 11, 12. Meanwhile, I'm looking at the THD and I'm seeing about 0.4. This 13K, 14, 15, 16. And also you see the amplitude. Like if I go back to 1K, see it's the hash mark here, it's just above it. So it's a little more than 2 frames per side. As I go up, right about there, it drops to, that's 22K, and that's when it just drops off. So yeah, 20K, okay, there's 20K right there. But look how it's almost 180 out again. That's kind of crazy, I think. Now look, I'm going to go to 10K, because I think 10K was also, okay, there's 10K, 20K, look at that. So 10 to 20K are almost 180, but now if I go 19, they're starting, the Okay, right there, 18, they're right in phase. Now see, I wonder if 9K they're back in phase again. Okay, 15, so 19 and 15, they're pretty close. 11, 9, they're coming. 8, yeah, they're almost right back again. Wow. I've never seen this before. Now that blows me away. Okay, now I'm going to pay attention to the THD meter, okay? Okay, it's 0.06 right there. It's kind of bouncing around. 19 is 0.02. 16 jumps up to 0.6, 0.8, 0.5, 14, 12 is 0.3. Now, you know what? Remember, I'm going out to 9 harmonics, so that's going way past after the frequencies dropped off. So that's not fair. Here, let me drop it down just to 2 or 3 harmonics. Okay. Here, I'm going to go back to 20K. What I did is I went to 2 harmonics, okay? Now right there it's 0.03, 19. Yeah, okay, now it's staying 0.03 or something like that. It's kind of going from 0.01 to 0.02 or 3. 15, 14 is 0.00. Yeah, it's still 0.002, let's say. So now I'm at 8K. Yeah, once you start dropping the frequency down below 15K, I think it was, go back up. Yeah, right around 17K it starts getting a little worse, but yeah, it's actually 0.00 all the way down. Okay, there's 1K. Here, let's go down lower. Okay, look at that. 600 hertz, they're almost in phase. 700, they're way out. 500, they're kind of close. And 400, they're way out again. 180. Wow. So you know that phase picture we saw? I think that was real. That is crazy. The gain's super flat, but the phase is all over the place. Alright guys, so hey, what do you think of that? Now, we only tested at low power, the 1 watt, 1K. I think that's kind of the standard, you know, take THD readings. And I did the sweep at that 1 watt. So, I think next video I want to take it up to higher power. You know, take it up to, I'd like to do 10 watts, let's say. And then after that, maybe do higher power even. So, let me know what you guys think. And what other kind of measurements you'd like to see. I didn't do the THD on, or the FFT stuff on the scope because I got kind of spun around on this phasing thing. What do you guys think of that phase? That kind of blew me away. I think that definitely has to be a digital filter because I've never seen an analog filter where it can just about flip-flop every few cycles or a few kilohertz, you know, difference. Seems like it just, the phase just kept changing. That was kind of crazy. Tell me what your thoughts are on that. What do you guys think of that? I think that's the first time I've ever seen it. Other Class D amps I've tested, I haven't seen that. And also, that noise. At low signal level, you see that oscillation, right? So it's like our audio signal is being carried on a carrier wave, right? But that's not intentional, of course. It's just a Class D being, you know, smoothed off. So maybe we could optimize that some and take some of that down. I think the idea for this eval card was to show how efficient the power could be and how flat it could be and meet those kind of specs. With THD was really low too. So because those frequencies, those oscillations, you know, several hundred kilohertz, that's, you can't even hear that. As a matter of fact, you saw how the output at 20K just dropped right off. So that high frequency stuff, you know, it's not very high amplitude. It's kind of riding on our signal that was what, 2.8 volts or whatever. We saw that the output, you know, I don't know how much that would heat up, say a speaker element, something like that, maybe a tweeter, because you know, you think three-way crossover, for instance, the high frequencies are going to be sent to that tweeter. So if you didn't roll the frequencies off. Now, as it goes through other inductors, it's probably going to get smoothed off, and you know, that would be interesting to send it through a speaker crossover and see what a Class D looks like at the actual speaker driver. That'd actually be really cool to see that. So I'll do one of those tests. But let me know what you guys want to see me do on this amplifier the next time around, because it'll probably be a few days before I can get to it, and I hope to post this maybe tomorrow if it doesn't take me too long tonight. And sometimes the editing on these things just is nuts. But anyway, I'll post it in the next couple of days, and it'll be at least a few days before I can post another video, unless I sneak in something else I could review. I got some multimeters to review. Anyway, hey guys, thanks a lot for watching. Patrons, really appreciate all your support. Takes as little as $1 a month to be a patron, guys, and that's really helpful. So, all right, hey, we'll see you next time. Thanks for everybody watching the videos and supporting it. The channel is up to 5K, I think I'm at now, which is pretty darn cool. It took me about 10 months to get to 1K, and then that was last October, November area, somewhere around in there, and now, you know, another 10 months to get 4K. So, wow, that'd be cool if by the end of the year I can get, I don't know, is 10K possible? I don't know. We'll see. All right, thanks guys. We'll see you next time.